Today I'll be covering the structural design aspects of two stadiums which we have recently completed in Kalinga Sports Complex, Odisha. So basically these are high performance indoor stadiums which is meant to prepare and train the athletes for international competitions so that they bring glory to the nation. So as a part of the presentation, I'll be covering two important units, that is the athletic, athletic high performance center on the top and the aquatic complex which is on on the second row. So I would like to thank Collage Designs because they were the architects for this and we had partnered with them for the structural design services. So now getting into the basic understanding of what exactly is athletic high performance, what all activities are being covered inside that. So it is basically an indoor stadium facility that provides with the perfect environment to train and compete and succeed. It comprises of about 200-meter athletic track and 100-meter javelin throw track, plus weightlifting areas, gymnastic areas, etc. Additionally, there is a 5-story residential facility for the players and a dining facility to meet the day-to-day needs. Basically, this is not just a competition area. It's also a on-ground training area which has motion sensing training cameras to monitor the athletes on their performances on a day-to-day real-time basis. So, well, this is an overview about the athletic HPC. Onto the left, you have the architectural plan, which is the oval green color, that is the athletic track, which is about 200 meters once you complete. And that is the athletic track, and in the center you have the other activities like the javelin throw, you have the shot put, you have weightlifting, gymnastic, everything happening. And in addition to that, there is 1800 spectators sitting on top of that. That is the magenta area just above the oval green patch. And on to the right, if you see, that is the completed image, which gives a glimpse of how it is encompassed. The athletic track is already in place, and you have the columns which are wide apart, and the entire composition in a glimpse. Moving to the key plan metrics. So if you see, the function spaces plays an important role in this structure because the column locations are defined or are revolving more on that. So onto the right, if you see, the building length overall is 152 meters, and the width is about 90 meters. So onto the left, you see there is a residential block which is 5-story, and that is separated from the rest of the building with a separation gap. If you see the yellow shaded portion, that is the epicenter of the sports activities. You have the athletic part, you have the javelin, you have the weightlifting areas, and the spectator seating as well. So the most interesting part is that you can't have any of the columns in between because that hinders the functional aspects of the architectural configuration, and the purpose itself gets defeated. So as a result, if you see, columns are permitted along the perimeter of the demarcated areas and along the building periphery. So which means the columns are about 70 meters apart. And to deal with this column-free 70-meter zone and the roofing, to identify a proper roofing mechanism, that was a complex affair. So in the initial stages, we had multiple discussions with the architect, with the clients, as to what should be the most befitting option for this kind of configuration. So different construction materials and methods were explored to complement the architectural and the stringent timelines. Primarily, there were two options put to the client and the architects. One was the entire building in structural steel. The second option was to have the roofing in structural steel and rest of the building in RCC. So keeping the architectural intent, stringent timelines and budgets, it was decided to have only the roofing in structure steel and rest of them in RCC. So if you see you can see the network of beams, the network of trusses and this clear span of 70 meters. This is the main truss. So these are the structural plans with with the trusses. Like the roofing area is about 1100 square meters. You have about 21 trusses, which is shown in magenta color. It's about majority of the trusses are about 70 meters, and as the plan geometry decreases, the truss span also decreases to that extent. So coming to the roof plan configuration, it's a network of trusses laterally supported by plan bracings and tie rods, in addition to the other activities. So if you see there is some catwalks happening within the trusses. These catwalks are meant for annual maintenance and to facilitate the maintenance of the cameras and the repairs of the lighting fixtures. So this slide depicts more on the RCC column and truss connection integration at the roof level. So if you can see, onto the top, you have the 70-meter truss, which is a kind of pitched truss, and the depth of the truss is about 3.3 meters. It is supported on steel corbels on the RCC columns. Mainly, SHS sections were deployed for the formation of the trusses. In addition to this, to mitigate the lateral forces and the overall stability, sidewall bracings were planned at the perimeter of the building, wherever it is conducive from the architectural aspect. So these are the construction phase images. If you see on the left top to bottom right, they are arranged sequentially. You can see the installation of trusses happening into the left, the starting one, and finally onto the right bottom, you can see that the trusses are almost complete. So in terms of transportation and the logistics, each 70-meter trusses, they were split into 4 pieces, and they were transported from the factory to the site accordingly. They were assembled on site, lifted and erected. The entire process of installation took about 4 days for each truss. So these are the uncompleted images of the athletic high performance center. Now moving on to aquatic complex. This is again an indoor stadium facility. This structure comprises of an Olympic-sized pool, practice pool, and a gymnasium for swimmers. It also has a residential facility for players and a dining area to cater to their needs. It has a spectator seating facility of 1,500 people. So this is the architectural overview. If you see the plan on the left, you can see that the central area is dedicated for the Olympic-sized swimming pool. Also, there is a practice pool with the spectator seating onto the top. And onto the right, you can see the as-built image, which gives the actual image of the site, the completed view. So this is a key plan showing the function spaces. Again, over here, the column locations are dependent on the function spaces. So here, if you see onto the right, it is the residential block, which is separated from the rest of the building by a separation gap of 50 mm. So the yellow spaces is the area which comprises of the swimming pool and the practice pool and the seating. So which is, again, defines the column locations. So the demarcation line shows the column locations. So both the columns are separated by a 50-meter gap. Again, dealing with the column-free zone of 50 meter and arriving at the most befitting roofing supporting mechanism, that was a complex affair. In the initial stages, here too, we had a brainstorming session with the architects and the clients to arrive at the most optimum solution. So in this case also, clients have decided to go ahead with roof supporting elements in structure steel and rest of them in RCC. So this is the roof configuration. So the magenta lines indicates the, the trusses, and the green ones are the plan bracing, which is providing lateral stability to the trusses. And again, there are network of catwalks through the trusses. This depicts the RC column and truss connection integration. Over here, the trusses are flat as compared to the athletic high performance center that was pitch roof. This is kind of flat, and the depth over here is about 3 meters, which is again supported on steel corbels on the RC columns. So a lot of planning was done in terms of how to complete this project in a very stringent timeline. As a result, most of the roof supporting mechanisms were related to steel. In addition to that, to mitigate the lateral forces and to arrive at the global stability, sidewall bracings were planned wherever it was applicable and necessary. Yeah, so these are the construction phase images. So again, from top left to bottom in a sequential order. So onto the left, you can see that the trusses are assembled, and to the right bottom, you can see that the building is complete. Only the facade is remaining. So here, the truss was about 50 meters, and again, it was brought in 4 pieces, assembled on site, and then lifted. The entire installation program was about 4 days for each truss. So these are the on completion images, the building envelope completed, and on to the right, you can see the interiors of the aquatic complex. So the structural analysis for both the stadiums were done in 2 different softwares, that is ETABS and robot analysis software. The prime objective was to determine how it is behaving structurally in terms of analysis, and to ensure the global stability and safety of the structure. Apart from that, it was also important to have a proper material efficiency, so both the models were evaluated, and we found that the results are more or less matching on the analytical front, and for the design purpose, ETABS was taken forward. So this project had an extremely ambitious deadline, that is, both the stadiums had to be completed within 15 months. So for such long span and time-bound structures, structural steel as a construction material is unavoidable. And it has been the instrumental reason, it has been one of the instrumental reasons for timely completion and satisfying the architectural intents. So with this, I conclude the presentation, and thank you all of you.